Integration is our third topic. Also sometimes known as an antiderivative, because it's the opposite of a derivative. Ooh, sorry, clicker not working and then it works. So antiderivatives and what's called an indefinite integral. Later on we'll talk about a definite integral. So you should be able to write a general solution for a differential equation. That sounds scary. There's an entire course in college in math where you do nothing but differential equations for an entire semester. Loved it. It was awesome. We're going to use some indefinite integral stuff, and we're going to learn about some new notation. You're going to get to practice the squiggly mark, which probably has a name, but I don't know what it's called. You'll see it in a bit. You may have already seen it. We're going to talk about some basic integration rules. So when we start, after we define what an antiderivative is, we need to come up with a method for finding them because we don't want to have to go through a big, long, scary process every time. Similar to what we did with derivatives, you'll recall with derivatives we started with that difference quotient, that limit as delta x approaches 0 of f of x plus all that business. And then we said, oh, that's silly. Let's just bring the exponent down and reduce it by 1. Yeah, we got a similar situation going on here. And then, of course, we're going to go from a general solution to a particular solution of a differential equation. Antiderivative. So here's the question. Let's suppose I have a function, 3x squared. And we call that f of x, little f of x. You'll notice we're introducing new notation here, which is capital F. So we've done already lowercase f, and then if you take the derivative of lowercase f, you get f prime. And if you take the derivative of that, you get f double prime. Well, what capital F represents is the function that I took the derivative of to get that. Gesundheit. Are you okay? It sounded like it hurt. Or it sounded like a cat being fed into a blender. Did you get any on you? Okay, good. So again, capital F is the function that when we take the derivative of it, we get 3x squared. So what is that function?
X cubed plus c.
Oh, you be quiet over there. Plus c, I don't even know what that means. How about x cubed?
Yes.
What's the derivative of x cubed? 3x squared. Okay? So, we get that. Capital F would be equal to x cubed because if I take the derivative of x cubed, I would get 3x squared. Or the derivative of x cubed is 3x squared. That process is called finding an antiderivative. What's the function that when I take the derivative of it, I'll get the function I'm talking about? That's what I just said. It's an antiderivative. Okay. Am I going too fast? We're good.
Good.
All right. But there are a number of solutions to the problem. What about x cubed plus 2? That work?
Yeah.
Why?
Because the derivative can.
The 2 goes away. X cubed minus 7. Yeah. X cubed plus pi. Yeah. X cubed minus e. Oh, yeah. Okay. How many of those are there? An infinite, correct. And that is a couple, sure. A couple would also be true. Okay. You said that already. And then we get what's called a family of antiderivatives. There are an infinite number of functions that when you take the derivative, you get that 3x squared. We don't want a whole family, but sometimes you have to deal with a family. Oh, that's kind of a slice of life type thing, isn't it? Sometimes you don't want your family, but you have to deal with them. I want to go on record saying I do like my family. I'm not venting some personal issues here in class. It's not the place for it.
There's a dog downstairs, sorry. Wait till after this video.
Okay. Let's not turn this into a contest.
That's funny.
All right. So,
Take out of the
how do we represent this infinite number of solutions? And as Mr. Smarty Pants over there already mentioned, we create a letter called C, and C stands for constant of integration. It's a capital C.
Okay.
And that capital C will be the bane of many of your existences. That means that over time it's really going to piss you off. Okay. Do you understand the term bane of your existence?
Yes.
It's like your arch enemy or what do you call it? Pet peeve. It's going to cause you a lot of grief because you're going to forget about that C, and that C is going to cause you all kinds of problems. In a free response question, it is common that that C alone, if you know nothing else, that C will get you 1 point. 1 point? What do I care about 1 point? Remember, it's 1 point out of 9. Really important. So don't forget about that C. And again, that's called the constant of integration. So when we take then, what function is it that we can take the derivative of to get 3x squared? Our answer would be that x, well, we're doing 2x now, but it would be x squared plus c. And that represents the infinite number of solutions. You with me so far? Good. Okay, so this is now a differential equation. Differential equation by definition means I'm looking for the function that generates that function. So if y prime is equal to 2, what's y equal to? What was that? Nice, 2x plus c. Not just 2x, 2x plus c. And so there's the antiderivative, but we got to stick that plus c on the end of it. And that's called the general solution, or the family of antiderivatives, or the family of solutions. It all means the same thing. There's an infinite number of answers there. We good so far?
Yeah.
Now, I don't want an infinite number of answers. I just want that one function. So we can complete the differential equation by figuring out what c is. So instead of just 2x plus c, or 2x plus 1, or 2x minus 1, or whatever it is, we want to figure out what c is. In order to figure out c, we need some extra information. But first, some notation. This is where things get fun, because you got to draw a new symbol which you've never drawn before, and people have a hard time with it. So here we go. That squiggly mark has a name. I just don't know what it is. It's got to have a name. Everything has a name. Adam, do you know? What's it called? No. I mean, do you know what the actual symbol is called? Like, for instance, this is, yeah, this, that means at, but it has a name also.
What is it?
I don't know what his name is. But there's also this one from your box of Cheerios. This is an ampersand, correct? So this usually means and or Cheerios, but it's
Procter and Gamble, right? It's not
no, it's General Mills.
Oh.
It's like a distorted G, but it's an ampersand. So this has some name. I just call it the squiggly mark.
It looks like
Okay.
a musical note.
It does a little bit, yeah. I guess.
Good.
Alright,
Good
sorry,
observation.
Timmy.
Timmy, does it look like a musical
It's a
note?
forte with a little line in the middle.
I'm sorry. What was that?
Looks like a forte.
Like a forte symbol.
Matt Forte? That looks nothing like Matt Forte. He's short and stocky.
That was such a bad joke.
Alright.
I just said it looks
So,
like fantastic.
This is some function that we take the antiderivative of that function, and we will end up with that capital F. So notice we're talking about now capital F, F prime, and F double prime. So what would the antiderivative of F double prime be? F prime. And what would be the antiderivative of F prime? No one heard my voice crack there. We'll just go with it. It's not recording or anything. And then the antiderivative of F would be capital F. Okay, so the derivative of capital F is F, the derivative of F is F prime, et cetera, et cetera. So now we have to slide back and forth. So we did derivatives one direction, then we're going to start going backwards for these things called antiderivatives. The thing that you're taking the antiderivative of is called the integrand. What's the matter?
We're just taking, isn't that just the function? Taking the antiderivative, like,
But it has a name. That's like saying, well, isn't that just the person who sits next to you in calc class? She has a name,
okay.
okay? That thing is called the variable of integration, dx. Extremely important. Your second bane of existence. You will forget that, and it's really important. The reason that's important is it tells you what letter is my variable. Okay, so this is telling me the antiderivative with respect to x. That's the variable. And then that we already talked about is the antiderivative, and then that c is the constant of integration. So we want to use the proper terminology when we're talking about these things. This whole thing is called an indefinite integral. Because we are indefinite to the actual solution. It's not a definite answer. Got a whole bunch of them. Notice I used the word synonymous, so I was feeling saucy. Jake, what does synonymous mean?
Cinnamon.
Cinnamon.
Say it.
What did you say?
I said cinnamon.
Cinnamon.
You still said cinnamon.
Did I say cinnamon?
It sounded like you said cinnamon, right?
You definitely said cinnamon.
Cinnamon.
That's last recording.
Okay. Just move
My
on.
word.
What's a synonym?
A like term is the same thing.
Like term or same thing? Like C and C?
Like, it means the same thing.
I see that I'm on the sea.
No, it means the same thing.
Different words, same meaning.
That would be
The-
Like dog and canine.
No,
Like Emma and the person who sits behind her. Alright. We would like to come up with some rules because
Integral.
doing that over and over again and just experimenting isn't going to work for us. Being in a math class, we want a specific rule that tells us exactly how to find the antiderivative every time. So change the notation a little bit. Now I'm taking the antiderivative of f prime, which would give me f. Okay. Doesn't matter what you call it. If we take the antiderivative of f double prime, we talked about this already, you get f prime. So just being comfortable with the notation going backwards,
Wait, why do you need the squiggly line again?
because that tells you that you're taking an antiderivative. It's just like when we were doing derivatives and you called it a prime, or you put the d over dx in front.
Oh.
It's the notation to say, yo, take the antiderivative. The yo is optional, by the way. Okay, so just more notation. Notice if I take the derivative of the antiderivative, it gets us back to where we started. Does that make sense?
Yeah.
Don't change it.
I'm not gonna change. I'm gonna stay the same wonderful person that I am.
Wait, so what does the variable of integration do again?
So bad.
The constant of integration.
The dx.
dx tells you which of the letters is the variable. It is possible that you'd be taking the antiderivative of something like xy dx. So that tells you, yo, x is the variable, y is just that constant thing.
And yo is still optional.
Yo is, again, optional.
Okay.
It's the Breaking Bad approach to math.
Did you finish it yet?
Oh, yeah.
Oh.
What are your thoughts?
I finished Breaking Bad in case anybody is interested.
No, but remember
What are your thoughts
we
on
talked
it?
about it once.
Unbelievable.
Really?
Most incredible thing I've ever seen. Greatest TV show ever.
What's your next show?
There's nowhere to go. There's nowhere
that I'm
to
gonna
go.
binge on. I'm just trying to get caught up.
I don't really like it.
Yesterday I watched a lot of Walking
I
Dead.
don't like it either. Because you watched it.
Anybody a Walking Dead fan?
Yeah.
See, the probably were.
Oh, the premiere of this season was unbelievable.
Yeah.
American Horror Story
Don't
is
get
good.
so
I've heard
finale
that.
was
I've
even
heard
better.
like every one of those. They're like,
I really like the second one, The Insider.
okay.
So you really like it?
But they're independent, right? So you could start with any one.
Yeah.
Actually,
Same actors, different stories.
the writers,
Some of the same arguments.
the writers just announced they're gonna like combine all those like that, connections, yeah. Yeah. So anyways,
I haven't watched
integration.
Yeah. So if you take the derivative of the integration, you get back to where you started, which makes sense. If you take, in that second line, also if blah 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 equals f prime of x, or capital F of x, if you take the derivative of capital F of x, you get back to f of x, and the derivative of c is 0, so you get back to where you started. Okay, so how do we do this? How did you figure out that the antiderivative of 3x squared was x cubed? In other words, we know when we take the derivative, you take the exponent, you bring it down in front, and you reduce the exponent by 1. Basic derivative rule. How am I going to go backwards?
Would whatever, wait. 1/4 x to the 4th plus c.
1/4 x to the 4th plus c.
The derivative of that.
Okay, so you're telling me that if I take the derivative
trying to
of
think what it
1/4
said.
x to the 4th plus c, I'll get x cubed?
The derivative, wait, what did I just say? I'm gonna write it down.
Okay? I'm repeating what you're saying to make sure I'm understanding correctly. You're saying that if you take the derivative of 1/4 x to the 4th plus c, you'll get x cubed.
Yeah.
You do? Good. Alright,
Oh, you guys.
so
Pretty much just me.
what if my function is x to the 4th, Grant?
Uh,
What would be the antiderivative of x to the 4th?
1/5 x to the 5th plus c.
Okay, suppose my function is x to the nth.
1 over n plus 1 x to the n plus, wait, all the, that's got lost.
Oh, no, I don't know.
It's 1 over 1 times x to the n.
No, it's 1 over n plus 1 times x to the n plus 1 plus c.
Plus c. Well done,
How do you know that?
because he's really smart.
Because
So there's the rule.
multiply, it has to equal 1.
And this is just for a plain old polynomial, we have no coefficients in front, we're just looking at x to the nth. Now the fun part, Grant, can you summarize that in English? What did you do?
No.
No, okay. Somebody else? Because I know you're not gonna memorize that fancy rule. You want something simpler that's got a buzz phrase to it that you can remember. Go ahead, man.
Is it add 1 to the exponent and divide the leading coefficient by the exponent?
Add 1 to the exponent and divide the leading coefficient by the exponent. Does that make sense?
By the exponent plus 1.
By the new exponent. Take the exponent and add 1, so 3 plus 1 is 4. Divide the leading coefficient by that number, which is 1 divided by 4, and make that the new exponent. That sounds pretty good. Can we live with that?
So they just add C.
And yeah,
Which is pretty much what I just said there. And then don't forget your plus C, which many of you will.
I just
What'd you say? That's what I thought.
she's trying to keep the plus 1. She says I.
How do your squiggly marks look, by the way?
Terrible.
My first one's good, my second one sucks.
You'll get better at it. Ooh. You need somebody to draw your squiggly marks, ask Fox. She's got it under control. Okay, so notice, this is really important. This is the basic rules for taking antiderivatives.
There is no.
Wait, hold on.
Solid.
There is no product rule. There is no quotient rule, and there is no chain rule. Do not try to use them. You will get it wrong.
I can do that.
Wait, don't celebrate yet.
There's no rules.